All right. Okay, looks like I'm getting volume. I am back in my classroom. Hello. Okay. Today's plan. So I've got camera here and I've got screen here. So if it looks like I'm looking that way, that's the reason why. What we are going to do today is get some data to calculate the density of some stuff that I just found around my classroom. And I'm not entirely sure what we're going to do with this data, but I know we're going to calculate the density. So here's what I went and found in my classroom because it's my first day back in a few months. I have a golf ball. I grabbed some random piece of metal. I think that's probably copper. I grabbed some modeling clay. I have a wood triangle, and I've got a couple of metal cylinders. And being the smart Chucky that I am, I've got a couple of graduated cylinders of a couple of different sizes, because I think if I want to measure volume, I'm going to need those. So all we're going to do in this video is we're going to get some volume data, and then we're going to get some mass data. Okay, so let's do the easy one first. All right, so if we want to know the volume of our wooden triangle, we should probably record this. So I'm going to write wooden triangle on a piece of paper. Wooden, there it is. Wooden triangle. And maybe I want to do volume, and maybe I want to do mass. Woo. All right, wooden triangle, volume, and mass. Okay. The volume of a triangle is going to be the area times the depth. And there's the start of length. Okay. So if we just have our triangle, then the area of the flat surface, hopefully, maybe you guys know this, is going to be 1/2 base times height. So the area of a triangle is 1/2 base times height. And since we have a three-dimensional object, we're also going to multiply it times the depth. So I am going to describe the area of the triangle as 1/2 base times height times depth. All right, so let's get some measurements here. Grab a ruler. The height of our triangle, is 5.5 centimeters. So we've got 5.5 centimeters. The base of our triangle is 11.1 centimeters. And the depth of our triangle is 3.7 centimeters. So we've got 11.1 centimeters, 5.5 centimeters, and 3.7 centimeters. And our formula is 1/2 base times height times depth. All right. So you should have recorded that. I just kind of sketched it out. Okay. 1/2 base times height times depth, 11.1, 5.5, 3.7. All right, let's do the other easy one. Now notice I didn't calculate out the wooden triangle yet. I'm just getting measurements. Guess what you guys are going to do? All right, so we've got our metal cube-like thing here. And that one, hopefully you know, that's going to be base times height times depth. And so this guy, what are we going to call this guy? Let's call this guy the metal block. So I'm going to do the metal block, and I'm just taking some basic notes here. Maybe I'll have you guys type this up. All right. So my metal block is 1.0 centimeters. You guys can even see. Yeah, that doesn't show up very well. All right, so that's 1.0 centimeters. And 1.0 centimeters. All right, so we've got 1.0 times 1.0. And it is 4.9 centimeters long. So my metal block, which is probably copper, but maybe there's a way we can test that. 1.0 times 1.0 times 4.9. All right. What else do we got? We have a couple of metal cylinders. Now, if you do not know, the volume of a cylinder is, and I'll even write it down here for you guys. The volume of a cylinder is equal to pi r squared h. Volume of a cylinder is pi r squared h. And if you want to just do an estimate, pi is about 3.14. And then r squared, we'll talk about how to do that in your calculator if you don't know how to do that. And then h is the height. And if you don't know r, we'll have a little lesson in r right here. So the distance all the way across the cylinder, I'll grab my big cylinder here. The distance all the way across the cylinder is 3.0 centimeters. The distance all the way across the cylinder is 3.0 centimeters. So that is the diameter. So the radius, which is the distance from the center to the outside, is 1/2 the diameter. So since all the way across is 3, then my radius is 1.5. All right, so I am going to do the big metal cylinder, okay? Big metal cylinder. And my R is equal to 1.5 centimeters. And then the other measurement we need is the height. And the height is 3.4 centimeters. So my R is 1.5 centimeters. And my height, I forgot the number because I'm old, is 3.4 centimeters. Now, maybe something we want to test is, are these two metals the same metal? Even though this guy's shiny, maybe this is just polished. So let's see if these two guys are the same metals. One of the ways we could test that is to find out if the density is the same. That wouldn't be a guarantee, but if the density wasn't the same, we would know that these aren't the same two metals. Now, if they have the same density, they're probably the same metal, but they could be different. But if they have a different density, And we know they're not the same metal. So let's do the little metal cylinder. Now, I'm assuming that you guys are now smart enough to record your own data, so I'm not going to show you every single thing. And you would just flip to the end of the video and write down all of my stuff, and that would be boring. All right, so the diameter all the way across is 1.8. So the diameter, which is all the way across, is 1.8, which means my radius is equal to 0.9 centimeters. 0.9 centimeters. And my height is 3.1 centimeters. My height is 3.1 centimeters. Okay, so we've got the wooden triangle, the metal cube, the big metal cylinder, the little metal cylinder. Let's do our last two guys. We got golf ball, and we've got piece of modeling clay. All right, now, a cube has a volume of 4/3 pi r cubed. That is the formula for the volume of a cube, but I don't think I want to work that hard. There's another way that we could measure volume. We can just displace water or displace a liquid. So the reason why I grabbed my two graduated cylinders here is because I'm feeling a little lazy. And I don't feel like figuring out 4/3 pi r cubed. So I'm going to write down golf ball. And instead of measuring the diameter and calculating the radius and then doing 4/3 pi r cubed, I'm going to do the lazy man's volume measurement. I'm going to grab a graduated cylinder. I'm going to measure the initial volume. The initial volume is 165. 165. And I'm going to drop the golf ball in. I'm going to roll it down the side so it doesn't splash. And the volume went from 165 to 248. So the volume went from 165 to 248. And I'm thinking, if we subtract, then we can figure out the volume. Okay? And number two, now, I could try and make my modeling clay into what's called a regular solid. A regular solid is something that has a consistent shape. This is kind of an irregular solid. It has a weird shape. Irregular solids don't lend themselves to like length and width and height. So what I can do with my modeling clay is I grabbed the smaller graduated cylinder so I could get a more accurate measurement. And my initial volume here is 71.5 milliliters. So my initial volume is 71.5. And if I drop that guy in there, it goes up to 89.7. 89.7. All right, so we went from 71.5 to 89.7. All right. So your task, before we talk about mass, is to calculate the volumes of these guys. Okay? And then I'm going to do another video where we do mass and then we'll do density. But first things first, I want you guys, as best you can, and I'll be on video if you need some help, to calculate the volume of each of our 6 objects.